Hello everyone, this is Mix K. Today I'm just going to go over the notes on the arrangement of electrons. So if you have not copied this vocabulary into your notebook, please make sure you do that and upload a picture to the bell work. So these notes need to be in your notebook. Make sure you're writing them down. But what we are talking about today is the arrangement of electrons. So before we did this topic, we talked about the atom, the structure of the atom, and how we find the number of protons, neutrons, and electrons. For today, what we're going to focus on is the electron cloud and how the electrons fill in the electron cloud. So the first word here we have is electron configuration. And I apologize if my dog is making any silly noises in the background. He's a little whiny. So our first word is electron configuration, and this is just a fancy way to say the arrangement or order of the electrons. Now, an electron we've talked about is a negatively charged particle, and it can be found in the electron cloud, which is outside the nucleus. Now, what we can actually do is split up the electron cloud into smaller areas. So our electron cloud is the whole space outside the nucleus, and we can split that up into energy levels. Now, energy levels are areas where electrons have the same amount of energy as each other. So if two electrons are in the same energy level, they're going to have the same amount of energy. As we go further away from the nucleus, we get more and more energy levels, and the electrons need more and more energy to get there. Orbitals are even smaller than energy levels, and they can only hold 2 electrons. So if you think about it like a city, the electron cloud as a whole is the city. We can split up our city into streets and roads, kind of like how we can split up the electron cloud into energy levels. And then we can split up those streets and roads into houses, like we can split them up into orbitals. Each house can only hold a certain number of people, just like each orbital can only hold 2 electrons. Now, we talked a little bit about ground state and excited state with our flame test lab. Ground state is when the electrons have the lowest energy possible. Okay, so they have the lowest amount of energy. They're usually closer to the nucleus. When they gain energy, they move up to the excited state. So they have more energy than they did before. And so they move further away from the nucleus to a higher energy level. Now, eventually that electron will lose that energy and move back down to the ground state. This is kind of like your ground state is kind of like when you're hanging out in your house, you have your lowest energy. Maybe you eat a snack, you have some coffee, you move up to your excited state, you're able to leave your house, go run some errands, go to your friend's house, but eventually you run out of energy and you end up back at your house, back at your ground state. Now, an octet is 8 electrons. This prefix oct means 8. Like an octagon has 8 sides, an octopus has 8 legs. An octet is 8 electrons. And this turns out to be the magic number for our atoms. Atoms are the most stable when 8 electrons fill their outermost energy level. All the electrons will be paired up. So, there we go. So we have this rule called the octet rule. And it says the outermost part of our electron cloud has to have 8 electrons to be stable. Now, stable just means it's not going to change. If it's unstable, it's going to change. If it's stable, it stays the same. So atoms that do not have 8 electrons are going to bond together so that they can get 8. So these outermost electrons are so important, we give them their own name. We call them valence electrons. Sorry that the little thing in the corner is kind of in the way. Okay, and valence electrons are the outermost electrons, and they take part in bonding. So for the rest, the next couple of units, we're going to be thinking about these things a lot. Atoms want to have 8 valence electrons. When they have 8, they're more stable. And if they do not have 8, they are going to bond until they get 8. So let's visualize this a little bit. Let me see if this will work just right in the screen. So when we first think about atoms and electrons, we think about the electron just spinning around in a little circle. But it's really not like that. the electron, oh, let me mute this guy, we don't need to listen to him. The electron actually moves around really, really quickly. So fast that we can't actually pinpoint exactly where it is at any given time. So it might be here, it might be there, it might be over here, it might be over there. But if we take a time-lapse video or a picture of this electron, what we'll start to notice is some very distinct shapes. And so what we end up with our first electron is the shape of a sphere. That electron has a high probability of being found within that sphere, within that space. Now, there are no walls holding the electron in. It just has to do with the energy. So if an electron has the lowest energy, it's found in this sphere of space outside the nucleus. Excuse me, no, come here. Sorry, hold on one second. Okay, so if we want to look at some more shapes, we're going to look at this video over here. Let me mute it. And we're going to see a periodic table in the background because as we go through this video, we are adding one more electron. And so that is making it be a bigger element. So here we have one electron. We can see that sphere shape. If we add another one, it keeps being a sphere. And it keeps building and building and building. And we start to see these weird shapes coming in. Those weird shapes, there's a reason for them. We know they're these shapes because of the observations we've made. But the reasoning for the shapes, we're not going to really get into it. It has to do with the amount of energy. And if you take chemistry in college, you'll take a whole class on quantum mechanics and learn how we know why these shapes are the way they are and how the electrons act this way. All you guys need to know is it has to do with the energy. But if we keep building up our atom, we can see these different areas where it's most likely to find an electron. And as we go out and out, those electrons get more and more energy. And it builds and builds and builds outward. So the lowest energy is near the center, and the highest energy is towards the outer edges. Okay. So you can see the shapes a little bit more clearly. I don't want this one to play. Bloop. We can, sorry guys, I keep like trying to skip ahead, but I keep skipping this slide. Okay, so we can see the shapes coming in. We have spheres, we have this dumbbell shape filling up. As we go and go, we get bigger and bigger atoms, bigger and bigger electron cloud, and those electrons are bound further and further away from the nucleus. Okay. Now, for this next part, I want you to make sure that you've done the pair deck link that I've added if you missed class. But we're just going to go through some of this information. So what pattern do we notice as we go across the periodic table? As we go across the periodic table, the number of sticks is going up. Now, these number of sticks represent the number of valence electrons. So as we go across, the number of valence electrons increases. As we go down a group, we have the same number of valence electrons. So when we go down a group, our valence electrons are going to stay the same. Now, the last thing here, the element that does not fit this pattern is helium. And we're going to keep coming back to helium to talk about why it's different. It only has 2 valence electrons, but it behaves more like the noble gases, so we keep it in the noble gas section. It does not behave like these elements over here, so it's going to stay up on top of the noble gases, and we'll talk more about why it's here and why it only has 2 as we go forward. Now, just to go through, all the elements in group 1 have 1 valence electron. All the elements in group 2 have 2. We are going to skip the middle of the periodic table. The middle of the periodic table, the transition metals, do not follow this pattern. So there's a whole set of elements in this space here that I've cut out, and I'll show you that on our periodic table in a minute. But just know that we skip those transition metals. They follow a much more complicated set of rules, and if you decide to go into chemistry, you will learn all those crazy rules in college. But for us, group 1 has 1, group 2 has 2, we skip the middle. Group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8, except for helium, which only has 2. When we look at our periodic table, we can see that I've actually given you the number of valence electrons right at the top here. So you can see 1 Ve minus means 1 valence electron for group 1, 2 valence electrons for group 2. We skip the middle, 3 valence electrons for group 3, 4 for group 13, sorry. 3 valence electrons for group 13, 4 for 14, 5 for 15, 6 for 16, 7 for 17, 8 for 18, except for helium, which has 2. So if I wanted to know the number of valence electrons for magnesium, I would find magnesium on the periodic table, go up and see that it has 2 valence electrons. If I wanted to know how many sulfur had, I would find sulfur on my periodic table, go up here to where it's highlighted in yellow, and see that it has 6 valence electrons. The only ones that this doesn't work for is helium, which you have to remember only has 2, and then we skip the transition metals for this, so it doesn't follow that pattern. Now, when we look at the noble gases, and we look at their outermost ring, we're going to notice that they have 8 in their last ring, except for helium, which we said is kind of weird. But what's important about this is that when it has 8, all of the electrons are paired up. So the noble gases are following that octet rule. They already have 8 valence electrons, so they are more stable. Now, when this happens, all of their electrons become paired up. Okay, so they're all paired up. They have a buddy, which means that these atoms do not need to bond. Because they already have 8, that means each of their electrons already has a buddy. Now, if one of these electrons was missing, and we did not have 8, we have less than 8, that atom is going to want to work really hard to get 8 total. And to do that, atoms that have less than 8 are going to bond until they have 8. Now, because noble gases already have 8, they don't need to bond. Think about it this way. If you're trying to save up for something, you're going to work really hard to get the money that you need for that thing. Maybe you're saving up for a new phone, or maybe you're saving up for new sneakers or new gaming console. But you're going to do whatever you can to get that last 20 bucks you need for whatever you're trying to save for. Noble gases already have everything they need. They don't need to work for it. They're just like, I already have my 8 valence electrons. I don't need any others. So, I'm just going to sit here and do my own thing, and I don't need to bond. I don't need to do anything to get 8 because I already have it. So think of them as posh. They're called noble for a reason. The noble gases do not bond. They do not react because all of their valence electrons, the outermost electrons, already have a buddy. They're already paired up. They do not need to find someone else. Atoms that do not have 8 will need to bond so that they can get 8. Now, helium is special. It has 2, but those 2 are paired up together, which is how we know that they are not going to bond. They're hanging out together, so we're not going to see them in a reaction. They're not going to bond because their electrons are already paired up. So helium only needs 2 to be happy. Okay. Sorry, I've been talking a lot. So in review, the electron cloud is broken down into smaller areas. The electrons fill up the electron cloud based on their energy. Valence electrons are the outermost electrons that take part in bonding. And our atom's goal is to have 8 valence electrons to make it more stable. If they already have 8, like the noble gases, they do not need to bond. But if they don't have 8, if they have less than 8, they are going to bond with other atoms until they have 8 valence electrons. That is your magic number. Okay, I hope this video helps. Have a lovely day, everybody, and let me know if you need anything.